Hello, my name is Camila Pimentel, and this is another episode of the Digestible series. This time around, we will talk about gametogenesis. Gametogenesis is the process where we form the sexual cells, spermatozoid and ovum, that will later form the zygote, which later forms the embryo, then the fetus, and then we have a baby. This episode is like a two in one because gametogenesis is very different in women and men. You must watch our previous videos on mitosis and meiosis to be able to understand this one. So, let's begin. Both male and female gametes originate as primordial germ cells or PGCs. PGCs are stem cells that can differentiate into both female and male gametes. This picture is of a 2-week-old zygote. It's in the bilaminar disc stage. It has a layer of epiblast cells on top, and underneath is the hypoblast. These two layers are surrounded by domes called the yolk sac and the amnion. I wanted to show that during this week, cells from the posterior epiblast are selected to be primordial germ cells. Posterior meaning they are closer to the feet once the baby develops. Later, they migrate through the primitive strake during gastrulation towards the yolk sac in the third week. From week 4 to 5, they migrate towards the genital ridge, which is not shown here. Also, the image shows the epiblast, which is in a bilaminar disc stage. Gastrulation makes it a trilaminar disc. These terms will be explained in future videos. Male gametogenesis begins in the embryo, where the primordial germ cells nest in the sexual cords, surrounded by Sertoli cells, which are support cells. Later, in puberty, this process is in the testes. PGCs mature and differentiate into type A spermatogonia that rarely go through mitosis and act as reserve. They then become type A pale spermatogonia that are constantly in mitosis, and this in turn will differentiate further, and we will see the whole process in the next slide. For now, focus on this. It's important to know there's incomplete cytokinesis or cytoplasmic division, so the after cells are bundled together through cytoplasmic bridges. Through further differentiation, this becomes spermatozoa. So, we have type A dark spermatogonia, then becomes type A clear spermatogonia, which also undergoes mitosis a lot. In fact, I put it twice in a row to represent that. Then they become type B spermatogonia, which will differentiate into primary spermatocytes that will go through meiosis 1. Then the secondary spermatocytes will have meiosis 2 and become early spermatids, which will gradually transform into spermatozoids by shedding most of the cytoplasm as residual bodies, forming the midpiece, the tail, and the head. This is an enlarged picture of a spermatozoid. It's notable to note that they have an acrosome on their heads, which is not shown here. The acrosome is a structure which facilitates penetration into the ovum. The middle piece contains the mitochondria, which is the powerhouse of the cell, and is shed as the head enters the ovum alongside the tail. This is why mitochondria only come from the mother. Female PGCs undergo mitosis with incomplete cytokinesis, which is cytoplasmic division, forming oogonia cysts. These then differentiate into primary oocytes. The cyst breaks, and most oocytes break up. Some that have support cells around them remain and form primordial follicles, which are the sole reservoir for the female's entire life. 40,000 persist to puberty, and less than 500 will be ovulated. The primordial follicle then becomes the primary follicle. A surge of LH each month will cause the first meiotic division to happen, and the first polar body appears. And the secondary follicle forms as an antrum starts to appear in the middle of the follicle as the cells degenerate. Once the antrum is properly formed, we have the Graafian follicle. Let's view its parts. It has a theca externa and a theca interna, but only the theca interna is secretory and produces androgens. Then, the granulosa cells will use these androgens and transform them to estrogens. The first polar body may undergo a second meiotic division, and it could be a cause of fraternal twins. Once the Graafian follicle breaks during ovulation, the egg is free and it's surrounded by the zona pellucida and the corona radiata. It still hasn't undergone the second meiotic division. A polar body is a subproduct of meiotic division in females. It generally degenerates, it's where the extra DNA goes to. However, most of the cytoplasm stays in the ovum. The corona radiata is formed by granulosa cells, and the zona pellucida are glycoproteins secreted by the oocyte and the surrounding cells. The second meiotic division needs a sperm to penetrate the ovum, and a second polar body is formed. The process in which the sperm penetrates the egg will be seen in another video. The cumulus of cells that is left behind after ovulation becomes a secretory body called the corpus luteum. It produces progesterone and will promote the conservation of pregnancy if fecundation occurs. It lasts 10 to 14 days if the egg is not fecundated, and if fecundation happened, it lasts 12 weeks until the placenta takes over hormone production. Once the corpus luteum degenerates, it becomes a corpus albicans, which does not secrete hormones. And I want to give a shout out to the sources. First, we have an article called Transcriptional Control of Human Gametogenesis, which is by Fang et al. Then we have Spermatogenesis by the editors of Britannica Encyclopedia. And then we have Undifferentiated Primate Spermatogonia and Their Endocrine Control by Tony M. Plant, which is a very nice last name. We also have the article Histology Spermatogenesis by Swed et al. We have the web page embryology.ch, which is from Sweden and it's very, very informative. We have the histology guide, female reproductive system. I will leave the links below for all of these. And then we also have the book Langman's Embryologia Medica, which I use in Spanish. I will leave the link in Amazon to buy it. And the credits. So we have Camila Pimentel, which is me, the drawings, the editing, the script, the voiceover. Yes, Ibel, script clarity. Thank you very much. She did a lot of pointers. My family and dogs for the moral support, and you that's watching this video for making it to this point. If you haven't, please subscribe, give me a like, and leave a comment. Thank you.